Welcome back. Now, we're going to continue our discussion on log messages. Now, we've noticed that when we're far away from our actor, we're not going to see those log messages, as that actor is no longer relevant to us if we're way across our open world map. Now, I'd like to switch to a smaller map as we're learning and developing to make things easier for us. So what I'm going to do is go ahead and delete this BP item and save this map. And I'd like to go back to our starter content folder into the maps folder in there and open our minimal default map. Here we have a smaller map and we don't have too many things. I've sort of cleared out all the clutter and we can be sure that we'll see the log messages for any actors that exist in our world. Now, if I open my output log and hit play, I'm not going to see anything in the output log. I'm not going to see my begin play call message because I don't have any items in the world. The actor has to exist in the world that you're simulating in order for any of its code to run. So what I can do is go to my blueprints folder, and in items, I can take my BP item and drag it into the world. And now I can open my output log, press play, and there's my begin play message. So that's something important to know. If you're not getting that output log message, maybe check to see if you actually have that actor in the world. So now that I have one in the world, I can experiment further. Now let's open BP item. And we already understand how the print string message works. If we drag off of begin play, we can get our print string message. And if we compile and hit play, then we see that message at the top left of our screen. And if we drag off and type print string, we notice that there's another function called log string. And this one is similar to our UE log macro. We can type a message here and say message printed to the output log. And if we go back and open our output log and press play, then it's a little harder to see because it's not yellow like our warning message. It's gray like everything else. And we see that it's got log blueprint user messages instead of log temp. And our message printed to the output log message is right here. And also notice just above it we have hello. This tells us that our print string message, hello, also goes straight to the output log. So the output log catches those messages as well. So we have a couple of options from within blueprints. We have log string and print string. And we know that log string goes to the output log and print string goes to the screen and the output log. So that's great. Now print string, if we expand the dropdown, also has, in addition to its other inputs, a key. And this key, if we hover over it, we can see that its type is name. Now, key allows us to specify a value to determine the behavior of these print string messages. Now, if we leave it at none, I'm going to show you what happens when we have multiple print string nodes. I'm going to hit Control D to duplicate the print string that I had selected. It has to be selected for Control D to duplicate it. Now, I'm going to change the text in my first one to first print string, and for my second one, I'm going to change it to second print string. And I'm going to change the duration to 60 seconds for both of these so we can see these messages. Now, if I go ahead and hit play, take a look. Our first print string is here and second print string is above it. Now, this is just the default behavior. Newer messages show up on the top and we get both messages printed to the screen. Now, the key here allows us to specify a value to associate with a given message. And if both of these print strings are using the same key, then newer messages will replace the older ones instead of stacking up like they're doing now. So if I set the key to my first print string to 1 and the key to my second print string also to 1, then when I hit play, I'll only see the second one because the first one was replaced by the second message. But if I set my second print string to the key of 2, then when I hit play, I see them both because they're in separate keys. This allows us to have more control over our print strings. Now, replacing older messages can be useful when we're printing lots and lots of messages. For example, here we have the tick event. Now, tick is called every frame. As we're playing our game, the image on our screen is updated many times per second, usually as often as 60 frames per second, but sometimes even higher, as high as 120 on higher-end machines. Now, I can select my first print string and Control D down here to duplicate it and hook this up to event tick. And now we'll get this message printed to the screen every single frame. Now, I can remove that 1 from the key and press play, and we'll see that print string is just spamming the screen. That's because we don't have a valid key set. But if I set it to a key, such as 1, then we'll get this message printed to the screen, and it's not spamming because each new message is replacing the old one. Now, this can be useful if we want to see the value of, say, delta seconds. Delta seconds is a float value providing us with the amount of time that has passed since the last frame. So this is going to be a pretty small value, as frames don't last very long. We're talking the order of milliseconds here. Now, if I plug delta seconds straight into InString, I see a pop-up before I release the mouse button that says Convert Float to String. And if I release, I get a new node here. And we see that it's going in as green and coming out as pink. This is a conversion node. It says converts a double value to a string. Now, if we hover over delta seconds, we see that it's a float. But the conversion from double to string node can take a float as well as a double in as the input. Much like C++ functions that require doubles can accept float inputs. There's an implicit conversion going on behind the scenes. Now let's see what happens when we press play. Now, our message is showing us delta time, and it's going to be different for me than it is for you because our delta times might not be the same, and you'll notice that this value is changing. So every single frame, we're printing out that delta seconds value. It's 0.008333 seconds in my case, and it's changing from frame to frame. So delta seconds is not constant, it's constantly changing. So now that we understand this key input to print string, I'd like to see how we can print messages to the screen from C++. So I'm going to go ahead and delete all those nodes and compile and save. And let's open our Visual Studio project. Now here in Begin Play, I'd like to print a message to the screen rather than simply sticking it into the output log. Now to do that, we want to call a function that exists on the uEngine class, and if we type gEngine and hover over it, we see that gEngine is a pointer variable of type uEngine. Now, the pop-up says global engine pointer can be 0, so don't use without checking. Now, this is a pointer, and if its value was 0, that means it's a null pointer. And we can get a crash if we attempt to dereference a null pointer, which means we should check to make sure gEngine is not a null pointer. Now, this is a global pointer variable we can access from within any class here, and it has its own functions, such as, using the arrow operator here, I can start typing add Onscreen, and right here I see that there's a function called add Onscreen debug message, and the pop-up tooltip is also showing me the input parameters that this function requires. We're going to make use of this function, but not before we check this gEngine pointer. So we're going to make an if check here and check if gEngine. And if gEngine is a null pointer, then its value would be 0, and this if check would simply fail. We won't even reach the inside of the if statement if gEngine is not a valid pointer. Now, in most cases, it should be valid, especially by begin play. Begin play is usually called by the time gEngine is initialized. But it doesn't hurt to check, so we're going to make use of good programming practices and check our pointers before we use them. Now let's use this function. So we're going to take gEngine and use the arrow operator. We're going to use add Onscreen debug message. And as soon as I open my parentheses, IntelliSense pops up showing us that we have some input parameters we need to pass in. And where it says 1 of 2 with up and down arrows, this means that there are 2 overloads of this function, 2 different versions, and we can scroll through the different overloads to see what input parameters they require. We can keep this on 1 of 2 for now. And notice the first input, it's the key. And we know what the key does thanks to our analysis of the print string function. So we can use different keys for our different messages. We can use 1 for our key. And our next input parameter is the time to display. So we could use 60.f for a literal float value of 60. Now that means our message will be displayed for 60 seconds. Now we could just say 60 like this, which is a literal integer value, and this will result in an implicit conversion from int to float, but we can save the compiler the trouble of implicitly converting that to a float by simply providing a literal float value in the first place. So when we're using float values, we'll often use .f to specify that this literal value here is a float value. Now I'd like to see the next input parameter required by this function. So I'm going to hit Control-Shift-Space to pop up this handy tooltip again. And we see that the next input parameter has the type fColor. It's called display color. So that's the color our message will be. Now, if we type fColor and a double colon, the scope resolution operator, we can see some of the options we have. And that's because the fColor class has some static variables. Remember, static variables can be accessed on a class directly. We don't have to actually create an object of the fColor type in order to access its static variables. And it has static variables for each of the colors. For example, cyan. If we choose cyan, then we're accessing the fColor cyan. And fColor contains the color information, the red, blue, green values, as well as the alpha for a particular color. So we're going to use cyan for our log message. And Control-Shift-Space shows me the next input that we need. And this is of type fstring. Now, fstring is a type in Unreal Engine that contains a string, but it also has other helper functions related to strings. Now, we can create a temporary value of the fstring type by using fstring and parentheses. This means we're actually calling the fstring constructor and making a new fstring. And one of the constructor overloads for the fstring type can take a string literal. So we can say item on screen message with an exclamation point. And that will be the message we get printed to the screen. Now, if we hit a comma, we see that the next input parameter we need after the fstring is a Boolean called be newer on top, and by default it's set to true. This means that newer messages will be logged on top of older ones. And it has a default value, we know because of the equals sign with a value here. So this function is coded with default values built in for these input parameters, starting with this one. And the rest of the inputs that this function can take also have default values, which means we don't need to pass those in. So I can delete that comma and simply add my semicolon at the end, and now my on-screen debug message has all of the input parameters it needs. So we can add on-screen debug messages by simply providing a key, a time to display, a color, and a message to print. So now we can go ahead and see how this works. So I'm going to go ahead and save from Visual Studio and come back into Unreal Engine and do a hot reload. So let's hit the hot reload icon and have our live coding process started. And now that it's finished, I can close out of live coding and go ahead and press play. Now we see item on screen message printed to the screen. It'll be there for 60 seconds and it's cyan. So now we have another tool at our disposal, the add on screen debug message function, which is a function on the G-Engine global variable. So we can log things straight to the output log or onto the screen as we program our games in Unreal Engine. So this will be very useful throughout our careers as game developers. All right, so our BP item has more functionality. So far, it's only related to logging messages, so nothing too exciting just yet, but these are tools that we'll use as we're making our games, and they're extremely useful. But what if we'd like to, say, print the value of that delta seconds that we saw from event tick? So far, we just know how to construct a string from a string literal and print that message to the screen. In the next video, we're going to learn how we can print the value of delta time from C++. Now, in blueprints, it's called delta seconds, but in C++, it's called delta time. We'll learn how to log this in the next video. Great job. I'll see you soon.